Today we're going to talk about using probability to make predictions. And the truth of it is, probability doesn't do you any good to know the odds of something unless you want to be able to do something with it. They use probability all the time in the real world when purchasing things, especially. A car dealership is probably going to look at how many different colored cars are out there and what's the probability that somebody would have a white car, a red car, and if they're going to purchase 1,000 cars, they're going to purchase, according to that probability, a certain number of white cars, a certain number of red cars, a certain number of blue cars. So we want to be able to predict, using the probability, how many might happen. Okay? So if you look on page 221, this is your turn there at the bottom. It says a car rental company sells accident insurance to 24% of its customers. And I'd like you to kind of highlight that little piece where it says 24% of its customers. What is 24% as a decimal? 0.24. Probably the most important word, simple as it is right there. Of. What does of mean mathematically? Multiply. So I'm taking 0.24 times the number of customers. Well, how many customers does it say they have? 550. So for this problem, I'm simply multiplying 0.24 times 550. Somebody do that and give me the result. 132. Okay. What does this 132 actually represent? Specific to this problem, other than 24%, Wayne.
132 of the 550 customers purchased insurance.
This says that 132 people got accident insurance, right? That's what it specifically is telling. Feel good? It is very simple. We all right? I can go? The next your turn. In emails to monthly readers of a newsletter, 3% of the emails. Notice the phrasing again. 3% of the emails. Please be careful with the 3%. How do I write 3% as a decimal? 0.03. Of the emails. Well, how many emails did he send out? 12,372. Okay? It says the editor predicts that if he sends out 12,372, he's going to get 437 notices for undelivered mail. Do you agree with his prediction, yes or no? Explain. What does this come out with? Okay. Since I can't get part of one, I'm going to use 371. I'm going to get 371 emails returned, right? He predicted how many? 437. Do you agree with him? No. His prediction is too high, because 437 is much greater than 371. Good? One more.
I didn't even look though. I didn't even look.
Okay. Again, if I were reading this, on average, 24% of the customers who buy shoes in a particular store buy 2 or more pairs. One weekend, 350 customers purchased shoes. So I'm taking 24%, 0.24, times the 350 customers that bought shoes. How many can be predicted to buy 2 or more pairs? First question. What does this multiply out to? 84. 84 is the answer to the first question. There is a second question. It says, if 107 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? If 107 bought 2 or more pairs out of the 350, did more customers buy than were expected? Buy more than 2 pairs?
Yeah.
Yes. And the reason is 107 is greater than what? 84, which is what we actually would predict or predicted to purchase 2 or more pairs. Pretty good?
Yeah.
Pretty simple?
Yes. Maybe.
Okay. Please pay special note to what's on the bottom, because I'm not going home today the way I left feeling yesterday. Those people that create noise don't even know there's noise in the room. But those people that are listening to it, especially those of us that have to listen to it class period after class period after class period, it gets too much. And we as a class have got to do better. So this is not going to be the same as it was yesterday. It is not a chat session. I know you're going to finish early. It's either finish early or I give you more work. If you decide to take advantage of this extra time that you're likely to have, I will gladly print more work so you have something to do. Are we clear? Everybody understands that it only takes a second to print something up.